An electrode was first placed inside the axon by Hodgkin and Huxley in 1939 at Plymouth, and by Curtis and Cole in 1940 at Woods Hole. Hodgkin and Huxley first made a plastic cell and mounted it on a platform which could be raised and lowered like a lift. As Professor Baker shows, the axon held by the cannula was then hung in the cell, which was filled with seawater and connected to an external electrode. The internal electrode, which was not attached to the lift, was then placed vertically above the axon, with its tip in the cannula. It was centered with respect to the cannula and axon by placing a small mirror beside the axon, arranged so that a second image at right angles to the first was seen through the microscope. By adjusting the position of the cell, both horizontally and vertically, the cannula and axon were now raised up over the tip of the electrode, which always remained in the same line of sight. Hodgkin and Huxley found that as the electrode entered the axon, a negative potential with respect to the external seawater of about 65 millivolts was obtained. This was the resting potential of the axon, and although its existence had long been suspected, this was the first time it had been directly measured. Moreover, when the axon was stimulated, the action potential did not simply fall to zero during the impulse, but became positive with respect to the outside, shown by the overshoot of the action potential. This important discovery suggested that the nerve membrane, which at rest is mainly permeable to potassium, becomes primarily permeable to another ion during excitation. This other ion is sodium, since if its concentration in the external solution was lowered, the action potential immediately became smaller, by an amount depending on the sodium concentration. If, as these experiments suggest, the action potential was dependent on the passage of ions across the membrane, it was obviously important to measure the currents carried by these ions. To do this, it is necessary to hold the internal potential at a chosen value. This is the powerful voltage clamp technique, originally developed by Cole in America and applied by Hodgkin, Huxley, and Katz. This technique requires that an extra electrode, the current electrode, be inserted into the axon. For this purpose, a double electrode was made by winding very fine silver wires around a thin glass capillary. As the wire, which was only 20 microns in diameter, was wound on, it was kept taut, as Sir Alan Hodgkin shows, by dangling a small piece of plasticine on the free end. The finished electrode consists of two entirely separate spirals, insulated where necessary by shellac varnish. While it is inserted in the same way as the simple electrode, the information it gives is quite different. As a change of potential is imposed on the axon, as seen in the top trace, the currents flowing across the membrane are revealed in the bottom trace. The early downward dip, seen on the left, is the transient current carried by the influx of sodium ions, and it is superseded by an opposite and persistent current attributed to the outward flow of potassium ions.